Hey, you guys should feel really proud you've graduated from triangles up into bigger, more sides on polygons. We're going to look at angles in polygons with this lesson. So we already know that the sum of the angles in a triangle is 180. But this lesson, we're going to take it a little bit further. What about in a quadrilateral or an octagon, or really any polygon is our goal? How many degrees in the angles of a polygon? So we're going to do a little exploration to check this out. Now I've got a few pictures drawn here. We're going to kind of try to look for a pattern in this. All right, so first of all, a quadrilateral, which is the majority of this unit, and I hope you have your quadrilaterals foldable that we made in class, because we're going to refer to that in just a minute. You've got four sides on a quadrilateral, looks like this. We're going to try to figure out how many degrees this is by doing a little thing called triangulation. We're going to triangulate this quadrilateral by picking one of its vertices. This is a random pick. You can pick any one you want. I'm just going to pick this one right here. And I'm going to draw what's called the diagonal of this polygon. And the diagonal means I'm going to draw a segment that connects that vertex to another vertex that's not along a side. So I'm not going to come along this way or this way. Instead, a diagonal goes through your polygon, like this. So when I do that, you'll notice that I just divided this into two triangles. There's a triangle there, there's a triangle there. And so we want to put in this column, the number of triangles we got out of that quadrilateral was 2. Well, how many degrees are in the triangle? We already know that's 180. So if I take the first triangle and I get that angle, this one, and this one, I know there's 180 degrees in that. Then I do my second triangle, I've got the 3 angles there, 180 total. Now, if you look at all those, I've just marked all the angles of the original quadrilateral. So what we can conclude is that I have 2 triangles multiplied by 180 in each of those triangles. Let me put parentheses so that looks easier. 2 times 180 means I have 360 degrees in a quadrilateral. That's going to be true for all quadrilaterals. All right, let's go to a pentagon. How do I do this one? Well, I'm going to do the same thing. I'm going to divide it up into triangles by drawing in the diagonals from some random vertex. So let's take this one here at the top. If I do that, come across, draw that diagonal. There's another diagonal there. How many triangles do I get? 1, 2, 3. 3 triangles out of that pentagon. And so the angles in a pentagon can be calculated by just doing 3 times 180 degrees for each of those triangles. And I'm looking at 540 degrees for that. So all pentagons have 540 degrees in their angles all together. So if you get that, then let's try this 6-sided hexagon. Pick a random vertex. Let's come to this one. I'm going to draw in the diagonals. Whoa, nice straight lines. Thank you very much. And there we go. How many triangles did we get out of that? 1, 2, 3, 4. 4 triangles out of a hexagon. So altogether, the angles of a hexagon would be the 4 triangles times by 180. Hexagons have 720 degrees. You do this heptagon with the 7 sides, and pause the video and come back and let's compare our results. Okay, so I ended up with 5 triangles with my diagonals. You may not have done it from that vertex, probably you didn't, but you should have got 5 triangles also, and 900 degrees in that. So if we go forever with this, we could do this for any polygons. What patterns are we seeing here? No matter how many sides I have, can I figure out how many how many degrees the angles have? Well, I can't. So we're going to do an n-gon. You remember an n-gon is n represents the number of sides. And so if it has 20 sides, it's a 20-gon, or 80 sides is an 80-gon. Well, how many triangles would it get? Well, look back up here. When we did 4, we got 2 triangles. 5 gave us 3. 6 gave us 4. You should notice that it's always 2 fewer triangles than the number of sides. So the number of triangles I'm going to get would be n minus 2. And then taking n minus 2, and I'm going to put it in parentheses, that's the number of triangles times by 180 would give me the number of degrees altogether. All right, now's the time to get your foldable. I want you to pull out your foldable. You have a cover that says quadrilaterals. Flip it open, and on the back of that cover you should have a spot that gives properties of quadrilaterals. So what are the properties of quadrilaterals? You want to write these down. First of all, the definition, and yes, definition of a quadrilateral is a 4-sided polygon. You should know that one. And what we just discovered, in any quadrilateral, the sum of the interior angles is 360 degrees. Sum of the total, all 4 angles together, 360 degrees. You want to write that down too. All right, let's apply what we just learned. We've got the sum of the interior angles of a polygon is always n minus 2. That total times by 180. So this is how many triangles we get, times by 180 for the total. So let's apply it to this problem. We got to figure out the value of x and these missing angles here. So let's see, how many sides does this polygon have? Let's count them. Let's start here. I got 1, 2, 3, 4, 5 sides. So 5-sided polygon is a pentagon, but n equals 5. All right, so how many degrees are in that 5-sided polygon? Let's see, n equals 5, so that's going to be 5 minus 2 times by 180. 5 minus 2 gives me 3. 3 times 180 is 540. Now we just figured that out on our chart. So all these angles right here have to equal a total of 540. Let's just add them up. Let's take the 130 up at the top. Working our way around, I see an x. Adding these all up, 104 in there, add another 115 angle, and then our last angle is going to be x plus 13. So I have all 5 angles down, and that equals my 540 total that we came up with up above there. All right, you know the name of the game here, combine these like terms. How many x's? I see 2 x's in that whole list. And now the big list in numbers, how much is all that all together? 130, 104, combine it all. So I'm grabbing my calculator, 130 plus 104 plus 115 and 13. That makes a combined total of 362 is what I come up with. 362. All right, let's bring down the 540. Now I'm just going to subtract the 362 off of this side. So when I take away 362, I'm going to get 178 now. And then you know what to do, divide by 2, both sides by 2. That gives me 178 divided by 2. I got 89. So the value of x is 89. And our missing angles in our picture, this angle here, that's almost a right angle, but not quite, 89 degrees for x. And when we come here and we add 13 to 89, this angle becomes, oh man, I can't do it. How about 102? I sure hope I'm right. You guys are going to call me on that if I miss it. All right, a little bit of a different one. Now in this one, I want you to highlight this because you'll get a lot of problems that are really similar to it. And it's important that you recognize the vocabulary. You have a regular octagon here. So what does regular mean? You remember, regular means all the angles are congruent. So I'm even going to mark that. So each of the 8 angles that I have in this polygon, they are all the same size. We're going to figure out what they each are. Well, how do I do that? Again, I'm going to use my interior angles. All those angles together, and there are 8 of them, they all add up to what total? With my formula, I can say 8 minus 2 times by 180. 8 minus 2 is going to give me 6, and 6 times 180 is 1080. So if that's the total of each one, and remember they're all equal, then I should just be able to take my total of 1080 and divide it by the 8 angles. There were 8 angles in that. So how big is each one? 8 divided into a 1080, you need a calculator, grab one, that's 135 degrees. So each angle is 135 degrees around that stop sign. Cool. Okay, moving on, we're going to talk about exterior angles. Now we've done exterior angles with triangles before. You remember that that's where we extend a side out. We've got interior angles on the inside. Our exterior angles are on the outside. From extending out one side, all of these things are exterior angles. They're all marked there. So how do we figure out the exterior angle total? Let me show you with this little demonstration how we can figure out the total of the exterior angles. So with this, I'm going to just click some points to make up a polygon. We'll just start out with these 5, this pentagon, and it draws in these exterior angles. Again, notice that the sides have just been extended, and we get these 5 angles, one at each vertex on the exterior. Now, when I scale this down, what's going to happen? It's like I'm zooming out and looking farther and farther away from it. The pentagon gets smaller and smaller, and those angles come closer and closer together. And what happens when they get so close together that they really are all at one vertex? Well, we see this full circle from those 5 exterior angles. Think about how many degrees are in a whole circle. Come back up and we can see that those 5 angles just moving away from each other. Let's try that same thing with a few more sides. Maybe, oh, count this out. I don't even know how many this is. We'll close it up. So look at all those angles there. Now I'll do the same thing. When I scale that down, those angles draw in closer and closer. They're not changing sides. But look at how many degrees. Again, they make a full circle together. How many degrees are in a full circle? Okay, so that works with a lot of angles. It even works with just a few angles. Let's just do this with a triangle, a simple triangle. There's my 3 angles, and those exteriors, 1 at each vertex. Scale that down, and what do we see? Same thing again. So this is kind of interesting. How many degrees are in that full circle? If you're saying 360, you've been paying attention in class. Nice work. So we're back in business. What did we just see from that demo? When we take the sum of the exterior angles, and that's again 1 at each vertex, how many degrees did we find? And it didn't matter which kind it was. Yep, 360. So there's 360 degrees in the outside angles of any polygon, 1 at each vertex. Let's apply that to an example. Here we're going to find the measure of each exterior angle of a regular pentagon. Grab the highlighter and pay attention. We're going to go each exterior angle, and it's regular. And so again, that means that all the angles are equal. Well, if they're all equal, how many degrees is in each one? So we're going to take like this pentagon. They're all the same. And we're going to extend out those sides to make the exterior angles. Just draw them out a little bit longer. Oh, this kind of looks weird, like a stick figure just exploded or something. Anyway, how many degrees are in each of these exterior angles? All of them being equal. Well, we know the total. We know the total is 360. So again, we also know they're all the same. I'm just going to divide by the 5 angles and get me how big each one is, 72 degrees. Simple as that. How about this one? This is, again, exterior angles. We know the total is 360 altogether. And they're not all the same, but we still can figure this out. We know the total, like I said, is 360. Well, let's just add them up. So how many degrees do we have altogether? Well, we got 4y angle. We've got a 2y angle. Get them all in there. A 6y angle. And then last is another 4y angle. All those combined make how many altogether? 16. 16y for me, 360 on the other side. Let's divide by 16. 360 divides into 16. Let's see, calculator time. Yeah, I'm getting 22.5. So y is 22.5. Well, we got to figure out the angles themselves. So let's go back here, plug in 22.5. Let's take this one first. If I go 6 times 22.5, that's giving me 135 for this angle. Then jumping over here, 2 times 22.5, I believe that's 45 degrees. And then these 4y angles, 4 times 22.5 is 90. Got a couple right angles in there, 90 on this one. Let's see what we got on this next one. Find the measure of an interior angle. Ooh, interior, we're inside. And the measure of an exterior angle. So we're also outside of a regular dodecagon. I want to jump back a little bit. Go back to this where we were learning about this exterior angle sum, and I want you to notice something because this is going to help you in this next kind of problem. Notice that the interior angle plus the exterior angle, what are those doing? At each vertex, you take this interior angle and this exterior angle here. You got a linear pair there. So an interior and an exterior together make 180 degrees all together, and that can really help you with this type of problem that we're going to do. So really write that down, and let's use it in this example. Find the measure of an interior and exterior of a regular dodecagon. Now, I'm going to say that the exterior angle is going to be the easiest because that total is just 360. Now, how many degrees or how many angles are in a dodecagon? Remember, the dodecagon is 12-sided polygon. So a dodecagon has 12 angles as well. Let's take the 360 total and divide by 12 equal angles. And we're going to get 30 degrees for each of those. Now I can do my interior angle with my total, my n-2 formula, and I can figure out that way, but I'm going to do this with my relationship that an interior angle and an exterior angle make a 180 total. So all I have to do here is just take that away from 180, take away my 30 degree angle on the exterior, and I'm going to get 150 degrees. Now let me show you that that works. So pretty much you got a polygon looking like this. You extend a side. You got an exterior angle of 30 degrees. Yep, interior angle is going to be 150. Not 120, 150. Awesome. Okay, now last example. Each angle of a regular polygon measures 156 degrees. They're all the same. Each angle, now that doesn't tell me which kind of angle, interior or exterior. So here's something you got to know. When it doesn't say, they mean interior. We're on the inside of our polygon. So keep that in mind. We're on the inside of our polygon and every angle is the same, measuring 156 degrees. We just don't know how many there are. So I'm going to draw a partial picture of it. And let's just put down 156 degrees on each of these angles here. Now there's a lot of ways to do this. I'm going to just tell you the easiest way because I know you guys like to just hear the easy way first. So here's what I do. The easier way is to change my perspective on the problem and figure out the exterior angles. That's straight. So how many degrees would be on these exterior angles? Well, we can do that. This is just making a nice linear pair for me. So let's take 180 minus that interior angle. We've got 24 degrees on the outside. Each of these is 24 degrees, and we just need to know how many there are. Well, we know the total, again, on the outside is always that standard 360. So if I divide by the 24 degree angles, I can figure out how many there are. So quick calculation, 360 divided by 24, that gives me 15. Guess what? There's 15 angles on the outside. That means there's 15 angles on the inside. How many sides does it have? 15 sides. Okay, I gave you the easy way. Learn that one or else I'm going to teach you the hard way.